Hello everyone. Today we are going to be talking about chemical reactions. This is going to be kind of a continuation of our conversation last week on chemical changes, as well as getting into the idea and the law of conservation of matter. So the things that I want you guys to really be able to take away from this video, we're going to continue looking at evidence of chemical change, and then we're going to build on that. I want you guys to be able to explain how matter is conserved during a physical and a chemical reaction, and we'll get into all that. So when I say chemical reaction, that is when a substance goes through a chemical change. If you guys have notes, this is a good time to take those out and start writing just a few key things. You don't have to write everything, mainly the things that are underlined and anything that you think is really important. So the idea that a chemical reaction is when a substance goes through a chemical change. Last week I think I used both of them interchangeably, but chemical reactions kind of the more formal term. So when we're talking about chemical reactions, once again, it's that chemical change. The original substance is changed into a new substance, and that is what how it's different from a physical change. Remember, when we're talking about physical changes, nothing changes, nothing new. The substance that was there before is the substance after a physical change. Now, when we go through that chemical change instead, when we're talking about chemical change, chemical reaction, we're changing from the original substance into a new substance. And that happens through the rearrangement of our elements. So this is the exact same equation reaction that we saw last week with my elephant toothpaste when I made the big box of foam, because I had my hydrogen peroxide, so H2O2, and then it turned into H2O and O, oxygen, because we had our original molecule. It kicked off one of the oxygen to create water and oxygen. So another thing to remember about chemical equations, it's a shorthand way of describing the substances that are going into a reaction and the substances that are coming out of a reaction. We use chemical formulas to show this. We've kind of been introduced to chemical formulas through the idea of compounds when we were talking about properties of matter, and through last week we kind of dived into a little bit with the hydrogen peroxide. So now some terms to identify with that. When we're talking about our chemical formula, like this is our hydrogen peroxide, H2O2, and it's turned into our water and oxygen. Reactants are the initial substance, the first thing. So our hydrogen peroxide over here is the reactant, while our water and oxygen over here are the product. So reactants are the things that are reacting, and the products are the things that you get after the reaction. So chemical equations also have another function. They also tell us how many molecules are used in the reaction. So remember, molecule is like another word for the compound. So the elements that are chemically bonded create a molecule, like our one right here, or these oxygen molecules that are bonded together. The coefficient is the little number in front of the molecule, so like in front of my O2 molecule, because two oxygen bonded together makes a molecule. And it's also in front of our water molecule, H2O, right here. So it's telling you that there's two water molecules here, or in this case over here, on our reactant side, it's telling us that there's two O2 molecules. So here's our two oxygens bonded together, two oxygen bonded together, and we have two of those. So the coefficient is the number in front of the molecule, and it tells you how many are there. So the law of conservation of mass, this is something important that you should probably write down, so you can always pause this video and take notes. So the law of conservation of mass, it means it's telling us that mass, or matter, is never created or destroyed in a chemical reaction. Meaning the elements that were there before, at the very beginning of the reaction, are thereafter. So the elements of the reactants are rearranged to create the product. So the number of elements before will be the same after. So we're not taking away atoms, we're not adding, they're not being added into after. They're the same that went in as they came out. So for example, we have 2 parts hydrogen, we have 2 hydrogen molecules, and we have 2 oxygen molecules, and they go into our little reactant. And if you count them up, you have the same on both the product side. So we have 2 oxygen and our 2 hydrogen. They just got rearranged. Now we have a water molecule and an oxygen atom by itself. So nothing, it's the same amount of atoms that we had before as we do after. And then this is another example of those pictures. They get rearranged, our little hydrogen attached to the oxygen, we see that. So when looking at a chemical equation, you need to make sure that the equation is balanced to reflect the law of conservation. When I say balanced, it means that there's the same number of atoms before in the reactant side as there are in the product side afterwards. So if we look at our hydrogen peroxide turning into water, how many do we have? We have 2 hydrogen and 2 oxygen to begin with, right? With our hydrogen peroxide, so 1, 2, 1, 2. But then we followed over to our product side. We have 2 hydrogen and 3 oxygens because we have 2 here and 1 here. So it's not the exact same, right? Because we have 2 and 2 here, and now we have 2 hydrogen and 3 oxygen. So is this balanced? No. How can we balance it? We can add coefficients. So remember those numbers before? We can add that to our equation to make it balanced. So we can put a 2 before our hydrogen peroxide, and we can put 2 before our water molecule, and then let's count it up. So it's like multiplying. So 2 hydrogen, we have 2 of those, so 4. 2 oxygen times 2 is 4. Now let's look over here. 2 hydrogen times 2 is 4, and we have 1 oxygen times 2 is 2, plus our 2 over here, and that's 4. So this little number basically is like you multiply whatever atoms are in there by that number. So now it's balanced. And we'll get some practice on this, so don't worry if this is a little confusing right now. We'll get more practice with it later. So for example, our SnO2 plus H2, Sn plus water. So how would we balance that? Let's count it up. Well, we have 1 Sn molecule, 1 over here, so that's good. We have 2 oxygen here, because remember our little 2 down here means there's 2 oxygen, but we only have 1 oxygen over here now. Okay. But we have 2 here and 2 here, so that's good. So it's really our oxygen that is throwing us off. So what we would need to do is we would need to put a 2, I can reveal this, and then oops, reveal it so that we can talk about it. So we could put a 2 in front of our water molecule so that we now have 2 oxygen, because we need 2 oxygen over here, we have to have 2 oxygen over here. So we would put a 2 in front of our water molecule, but now we have 4 hydrogens, because 2 times 2 equals 4. So then I have to go back to this side and add another 2. So that now I have the 4. So let's count it up. So 1 SN, 1 SN, that's still the same. 2 oxygen. Now I have 2 oxygen on this side because we have 1 here times 2. And then we now have 4 hydrogen because we have 2 within this molecule, and then times 2, and the same on this side. So that's for that one. Now we have, let's look at our last one. N2, so we have 2 nitrogen, we have 2 hydrogen, and it becomes NH3. So we have 2 nitrogen on this side, but only 1 nitrogen on this side. We have 2 hydrogen on this side, but we have 3 on this side. So what numbers do we have to add to get it to equal out? Well, let's start with our nitrogen. If we have 2 nitrogen here, I want 2 here. I could add a 2 before our nitrogen, right? Or before our NH3 molecule, but that now means I have 6 hydrogen because I put a 2 here. Let me reveal it so we can look at it. We put a 2 here, which now means I have 6. So I need to add a number in front of our hydrogen to make 6. And so I would add a 3 here to make 6. Like I said, once you work with this, it'll become easier to understand. It's kind of a lot, but we'll get there. This is just for our in-person labs, so you do not have to worry about that. But that is the beginning, our intro to chemical reaction. Let me know if you have questions, and I will talk to you later.